1.5 Bond types. Today we're going to talk about the difference in the types of bonds based on what you might see in the lab. So if you run a solubility test, you can determine whether something is ionic or molecular if it's dissolved in water. If it doesn't dissolve in water, it's metallic or network covalent. Secondly, once you've boiled it down to that, you can see that only ionic substances and metallic substances actually conduct electricity. Electron glue. From doing the classifying bond types lab, we know that we can separate materials out into these four categories. For a quick review, ionic substances dissolve in water. So let's see, they dissolve in water. And which other one dissolved in water? Molecular. Okay. What conducts electricity in solution would be the ionic. We'll just call it electrons. And this in the dry state, also metals conduct electrons. And also, let's talk about the materials themselves in terms of how well they bend or break. Ionic compounds are said to be brittle. That means they break into pieces easily. Networked covalent substances have a tendency to be very strong. So these have high melting points. They're hard to break. Metallic substances, you can bend them. So we say they're malleable and they're ductile. That means you can stretch them into really thin wire. And molecular covalent substances are fairly weak. They have a tendency to have a low melting point. Ionic compounds tend to be solids at room temperature. Network covalent are very strong solids. Metallic substances can be mostly solids. They have varying melting points. Some are very soft at room temperature and some are very hard. And finally, molecular covalent substances, with their low melting points, a lot of these are gases and liquids. Although we do have solids as their molecular structure gets larger. Another thing that you can use to identify these is by their element types. Ionic compounds contain metals and nonmetals. An example of this would be sodium chloride. Sodium is a metal on the left, chloride a nonmetal on the right. Network covalent substances have a tendency to be two nonmetals, and they're usually carbon-based. So, for example, carbon in the diamond form, and also silicon. Silicon has a tendency to bond with oxygen to make a network covalent compound. Notice the carbon and the silicon are the common group 14 elements that create these very strong network covalent structures. Metallic substances, as you know, the metals are to the left of the staircase, so anything from the main group elements such as potassium to the transition metals such as iron. And then molecular covalent substances are nonmetals only, so nonmetals only. So you have the gaseous nonpolar molecules such as hydrogen and nitrogen, to more complex nonmetal structures such as, let's see, what do we have? Carbon dioxide. They're not all gases, of course, so you might have more complex organic molecules. And we can just come up with even solids such as glucose. Okay? Alright, that's it for section 1.5, and you've now completed your reviews for Unit 1. Let's look at why these different materials have the properties that they do. So if you start looking at the atomic level, you can see what's really going on. And so, for example, the blue clouds here represent the electrons on all of these models. So this, where the outer shell has a lot of electrons, this would be the negative anions in the ionic compound, and these are positive metal cations. And so we can begin to see that ionic substances, when you put them in water, you have freely flowing charges. This accounts for its ability to conduct electricity. Likewise, when you go to the metallic substances, your positive metals, as shown by the red spheres, are swimming in what is said to be a sea of electrons, the negatively charged blue area. So this, once again, because we have freely flowing electrons, we can conduct electricity, because in a sense electricity is just a movement of electrons. However, in these two types, we have electrons that are stuck. They're stuck in place. They can't move. So we can therefore not have conductivity or moving of electrons. Another interesting thing is if you look at ionic solids. Ionic solids do not conduct electricity because their ions are stuck in place. However, it's interesting that if you try to split this particle, such as, for example, chalk, you notice it's very easy to break chalk, and that's because when you go to break it, you actually force the like-charged ions too close together, ending in a repulsion or a fracture. Another interesting thing would be the property of metals. If you look at the property of metals, you'll notice that even though you have a bunch of positives in a sea of negative charge, what you can do is you can bend it and move it into all different shaped objects. And that's because you always have the sea of electrons that help act like the glue to hold the positives to the glue. So wherever there are positive metals, there are also the negative glue, no matter how you bend it. And that's what makes metals so amazing, and how we can build all different sorts of structures out of metals. So there you have it, a discussion on classifying bond types and why these different bond types have the properties that they do.